So in this session, we will discuss more about the polymorphism, means how many types of polymorphism we are having in the C#.NET. So mainly, we are having the two type of polymorphisms in the C#.NET. One is the compiled polymorphism, and one more is runtime polymorphism. So in the compiled polymorphism, the method name is same. So for example, let's say method name is calculate salary. The method name should be same to calculate the salaries for the sales employees, permanent employees, freelancers, whoever. For them, whatever preparing the calculate salaries are same, but whatever trying to give the sales amount, commission rate for the sales employees, okay, parameters are different. You see that, right? Some sales employees for the parameters are different. And coming to the permanent employees, here also something parameters are different. Hours worked, hours relate. And coming to the freelancers, the parameters are different. Now, in the compiled and polymorphism, your name is same, calculate salary is same, but it's having the different input parameters. That's called the compiled and polymorphism. So same method, different inputs, and we are going to take the decision at compile time. Compile time means before debugging. Before debugging, we are going to take the decision what kind of input parameters you have to pass to the respective method. And coming to the runtime polymorphism. So in the runtime polymorphism, if you see here employee base class, okay, which is having the calculate salary. Okay, so here base class you can assume that either in the abstract class or normal class. Okay, that is one kind of a base class which contains the calculate the salary. Okay, so now once you are going to give the reference this base class to the permanent employee or contract employee and freelancers. Okay, once the we are going to give the reference of this base class to the derived classes. Okay, so basically if you observe here calculated salary which is declared in the base class, I mean you can say something kind of method signature we have prepared in the base class, but the actual implementation about the calculate salary of base class will be implemented in the derived classes, permanent employee, contract employee, and freelancers. So once we are going to implement the calculate salary related logic in the permanent employee class, you might be do the calculate salary based on the different kind of logics, either bonus, salary. You can do some kind of calculations in the permanent employee. And coming to the contract employee, you can do, okay, so contract employee anyway, deductions are more in any company. So bonus won't be calculated for the contract employees. So those kind of logic you can implement under the contract employee classes. Now coming to the freelancers also, the freelancer employees having the some different kind of logics for the freelancers. They are not the full-time employees of the company, so they will be charged based on their works like hourly based. Generally, freelancers are collect the money based on the hours only. Okay, so because those are not the permanent employees or contract employees of the company. So freelancers, you can say advocates, chartered accountants, and high-level officials. So they will be work as a freelancers to the companies. Okay, so in this case, method name same type. Here method name same type. Here method we are inherited from the base class, so method name is same type, and whatever we are going to write the logic of their methods in the derived types, those logics are different. And uh, for Marvism we are taking the decision at runtime. So after debugging, logic will be implemented. So this is the compile time polymorphism and runtime polymorphism. So compile time polymorphism, also we can say that is the static polymorphism. It's a kind of a type of a polymorphism in a programming where the method to be executed is determined at compile time. I mean, before the debugging, and this is achieved through method overloading or operator overloading. So we will discuss method overloading concepts into the next video. And the main important key point of the compile time polymorphism here that method signature is same and the parameters will be different. So that is the compile time polymorphism or static polymorphism you can say. So, and we are going to take the decision, this one, the method or operator to execute is determined at compile time based on the method signature. So generally we are going to achieve this one by using the method overloading. And when we are going to apply the, this compile time polymorphism, the main important is that without inheritance you can do. So inheritance concept, without inheritance concept, we can implement the compile time polymorphism. So here inheritance concept is not required. And moreover, it supports the early binding, means the decision of which method or operator to invoke is made during the compile time by the compiler. So coming to the runtime polymorphism again. So runtime polymorphism also we can say dynamic polymorphism. It's a kind of type of a polymorphism in programming where the method to be executed is determined at the runtime based on the actual object type. So it is achieved using the method overriding. Okay, method override we have to do. So method override already we have done earlier session in the abstract classes. So in the abstract class, whatever we declare the abstract methods, those methods we overrided into the derived classes. So that concept we can say method overriding. So runtime polymorphism is the best example about that overriding concept. Anyway, we will take the one more example in this while we are going to explain about the runtime polymorphism. And one more thing is that we can do overriding not only by using the abstract methods, even we can do by using the virtual methods as well. So we will discuss this, virtual methods into the next session. Okay. So now coming to the key points of the runtime polymorphism, the main thing is here is that the decision about the runtime polymorphism we are going to execute during the program execution based on the actual object. So once we are doing the debugging of your code, so that situation we are going to decide uh, which method you have to connect. Okay, so that is the, it's a runtime polymorphism. And anyway we are going to use the method overriding for achieve the runtime polymorphism. Already we did method overriding on the last session. Again we will do that. And it supports the inheritance. So anyway this runtime polymorphism will support the polymorphism and it support the inheritance as well. So runtime polymorphism, it's a very important. Runtime polymorphism is only possible with the inheritance. It's a very 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 important note. So without inheritance you cannot implement the runtime polymorphism. Method overriding you cannot do without inheritance. Okay, so that is very important point, you have to note it here. And it supports the late binding. So the method call is linked to the implementation at runtime rather than the compile time. So this is called the late binding. So the my final words is that runtime polymorphism here method name is same type and it's having the different runtime behavior. So this compile time polymorphism, runtime polymorphism, related programs we will check into the upcoming sessions.